Well, thank you. Hello, React Europe. All right. So I'm here to talk about how I wish the internet was more fun. And here I am, at some point in the 90s, hard to see a little bit, but I'm there somewhere, using my first computer. Oh dear, microphone. Two of them. Wow, I can go either way. I started using the internet in the 90s. And in the 90s, this is what a typical website looked like. This was an era before we had discovered web design, right? Nobody had thought that the web needed to be designed. Everything was perpetually under construction. You found new content via web rings. Remember web rings? Something that I remember is Ask Jeeves. Has anyone ever asked Jeeves something? It was a fun site. What I remember about Ask Jeeves is you never really got an answer that you were looking for, but it was still charming, right? He gave you something. This, believe it or not, is McDonald's actual website, their original website, circa 1997. And if we zoom in, you'll see there's a little man ducking out to polish the arches. It's amazing. Animated GIFs. 90s in one term. This is their website today. And I think it'd be hard to argue, actually I'm gonna raise this, bending over. I think it'd be hard to argue that this isn't a better website, right? Like there's more information, there's photos of the food, you can figure out where the nearest location is, our food quality story, whatever that is. Even McDelivery, they'll bring the McDonald's right into your home. I tried it, it's thoroughly unsettling. But while this is a better website, they've lost the charm of their original website, right? It's like, it's bland. It's everything it needs to be and nothing more. And that makes me sad. So this talk is the Case for Whimsy, wherein I try to compel everyone to build more fun things, right? The internet would be better if we had more charm in it. And I'll show how to do some cool stuff in React. My name is Joshua Comeau. So I've used the word whimsy a few times now, and surely in the next half an hour I'll use it plenty more times. So here's a definition I made up. An unexpected flourish that sparks joy. It looks real though, right? Yeah, I like this definition. But with such a broad definition, you can find examples all over the place. So this is Unsplash's error page. You'll see the man is trying to get the ketchup out, and then like, oh no. Whenever you get an error in Unsplash, there's a different error message, or a different error GIF. So this one's my favorite one. Cat owners can relate to this. See, the cat can't get up. I could talk for a long time about cats and GIFs, but I don't yet have a way to create cat GIFs with React. Maybe that'll be my talk next year. This year I'd like to focus on interaction and animation. And the reason for this focus is that I find like this is the easiest way to delight our users, right? Like there's so much we can do in this space to make our users, to make really cool experiences, right? Interaction and animation. So let's look at an example. So I work for a nonprofit called Khan Academy. We're essentially an online learning platform. Our mission is to provide a free world-class education for anyone, anywhere. And one of the ways we do that, in fact, probably the main way, is through practice problems. So here we have limits from rationalizing. That sounds like calculus. And once the user gets 7 out of 7 correct, they get 100%, we wanted to like rain confetti down on the screen. We thought it'd be a nice touch. And this is the actual mock-up I got. And what's super exciting about this mockup is how little is specified, right? Like there's no rules as to how it's supposed to fall. I was lucky in that we already had some confetti on Khan Academy, so I was able to use what we already had and like update it a bit, change some things. And this is what I came up with. So you'll see that there's a bunch of pieces falling. Each has their own little physics and their own speed and angle and all that. Whenever I do stuff like this, I like to build a little sandbox. So like, where's my mouse? There it is. When I click on here, confetti falls, which is kind of cool. And oh goodness, this is going to be hard to see. I have this spin property, which gives it like a 2D spin along its z-axis. There's also a mouse. Yeah, I'm using the little monitor over there. There we go. There's a twist, which gives it like a 3D spin. What's cool is that there's a back face that's slightly different color. But you get the idea, right? There's all these parameters. You can change the gravity. And I find whenever I'm doing stuff like this, it's really helpful to have, you want to shorten the feedback loop so that you tweak a parameter and you can see what it does right away, especially when you're still developing it. So just like a cool thing that I think is worth doing. I built this with HTML Canvas, and whenever I work with Canvas, I like to create a little generic helper to kind of make Canvas nicer to work with. And so let's go through this. We have some props. We have a width and a height, and then there's this draw prop, which I like to think of as a render prop, but for Canvas instead of DOM. If I go way down to the bottom, you'll see that we're just rendering a canvas, and we're delegating everything that you specify. The only thing we're really doing is capturing a reference to that canvas, and we're storing it on this .canvas. so that when the component mounts, we can use that reference to get a context. We call this method called scale that we'll see shortly. And then we have this draw method, and we pass the context along. Whenever this component updates, whenever it re-renders, we redraw, and that allows our canvas to tie in nicely with the React lifecycle. And we'll see some cool examples with that. Then there's this scale method. We are not going to go into the scale method because it's not very fun, but what it does is it makes it so that our canvas behaves the same way on a Retina display or another high DPI display as it does with our regular monitors. And it makes sure it looks sharp and you have the same coordinate system. Whenever you work with Canvas, there's this gross chunk of code that you always have to bring along. We don't have to look at it anymore though, because it's in our component, out of sight, out of mind. So this is what it actually looks like. Oh, this is going to be tricky, I just realized. Well, let's do what we can. So I can change these numbers. This little chunk in the middle is this bit is just vanilla JavaScript. And I kind of like the delineation that this React component manages when it paints, and we're just specifying the instructions that it needs to paint. If I wanted to, I could change the color. Am I going to be able to do this? Green. Green, cool. But what if we wanted to animate this? So here's another example. Actually, I'm going to make this full screen. That should make life easier. When I click on this box, it moves. And if we look at how this happens, if I scroll down, we're not actually, this should look a little familiar. We're still setting a fill style, and then we're still drawing a rectangle. The difference, though, is that the rectangle's x and y parameters are coming from variables. And if we check, they're coming from state. If I scroll way up, you'll see that, actually, is it not there? Oh, no, there it is. There's an initial state of 0 and 0. X is 0, y is 0. And so when I click on it, I have this start animation method. And if we find that, the first thing we do is we stop the animation and we reset the state, and this means that I can click and it resets. But crucially, setState has a second argument, and it's a callback function that's called when the state has been flushed. And here we're calling this .tick. And tick is like an animation loop or game loop, and we're using request animation frame. And this is a way to tell the browser that hey, before you paint the next frame, there's a bit of work that I'd like to schedule. And the work that we have is to increment the x and the y value by 1. So it starts at 0, 0. Whenever the animation starts, we're updating that so that it moves to 1, 1. And then once that state has been flushed, we call this .tick again. And so it's recursively calling itself so that the next frame moves it over again. And this is kind of how canvas animation works. And it's neat because it's like a flip book, right? We're not actually saying, move this thing from here to there. We're just saying, paint it here, and then paint it there, and then paint it there, over and over really quickly. And we can prove this if we scroll down. I have this little line that I left unexplained intentionally. Didn't mean to mention something about that earlier, no. And when I do that, you'll see that we get this streak effect. And the reason for that is that we're no longer clearing every frame, so you see the previous frames. What I kind of think that's cool about this is it reminds me a little bit of React, where we're not specifying the transition. We're just saying, given this amount of state, paint what it should look like right now. And then we're just doing that really, really quickly. So it's kind of cool. OK, let's look at how it works. And I should apologize. You'll see these scissor emojis. I didn't have the time to go through all of the details, so this is going to be a high-level look. So you'll see that we have a width and a height that we're going to pass to the canvas. These are kind of all the props we saw in that confetti slide a little bit ago. Then we have this make it rain on prop, which I think is a kind of a fun name. Here we're only going to worry about click. So when I click on the canvas, we make it rain. Then we have particles. So every little piece of confetti I'm calling a particle. There's an array of them. They live in state. If we jump way down to the render method, you'll see that we're rendering a canvas. We have this draw method that we're defining, that we're passing. And then whenever we click on it, we're going to run generate particles. So we look at our draw. Now again, the canvas is passing the context to us. And then this should look a little familiar. We're clearing the rectangle to reset it. Then we're just going to iterate through the particles and just do the instructions to draw each one. So we're going to move the imaginary pen to where it has to be and rotate it and scale it so that every particle is where it needs to be. And then we draw image. And the cool thing about this is that the images are specified as a bunch of SVGs. And that way design can just pass us a little piece of confetti particle and we can paint it into the canvas, which is a cool trick. Then we have to reset the context's position so that the next particle is drawn relative to the canvas and not relative to the previous particle. When I click on it, there's that generate particles method. And so I have this little range utility that just generates an array from 0 to n. And we use that to generate a blank array full of what will become particles, and then we map through them, and we do kind of what you would expect for particle initialization. So we have props to control the min scale and the max scale. We pick a randomized value in that range, and then we figure out where it needs to be. We give it an angle and thus a velocity for both x and y directions. And then we have particles, so we push them into our state. Now, if this is where we stopped, what would happen? Well, you'd click on the canvas, and it would generate a bunch of confetti, probably slightly above the canvas, so you might not see it, but it wouldn't be animated. And if we want to find out how to make it animated, well, this is updating the state. And when we update the state, the component's going to re-render, right? And so we can hook into component.update, which will soon change to a different lifecycle method, but living in the present for now. And we're going to check if we're going from 0 particles to more than 0 particles. And if so, hey, that means we have something to animate, so let's do it. We have this tick method, which again looks a little familiar, requesting an animation frame so that we can iterate through the particles. And we're just figuring out, based on how old the particle is and how much time has passed, where it should be. So if it has like a given angle and trajectory, we can work out the math as to where it should be. And then we just push those particles into state and schedule the next one. And then this is not a very helpful method because it just shows that we're mapping through and like figuring out where the particles should be. And like that's kind of it. So this is a nice little example. Performance. So I chose to use Canvas for this. And I generally prefer SVG. The reason I chose Canvas for this is that it's kind of expensive to move a lot of things around at the same time with SVG, because it's just DOM, so you're limited by the DOM bottleneck. The other thing we actually do at Khan Academy is that we sneak around React a little bit. So here we're using React's lifecycle, and the code is much nicer when you do that. But there is a little bit of a cost to that because you're doing the reconciliation on every frame. The reconciliation is really cheap here because there's only like it's not a complicated tree, but it can still be like half a millisecond. And when you only have 16 milliseconds a frame, that can make a bit of a difference. Something I can imagine people saying is that like, sure, Josh, that's a fun example, but I'm working at Serious Company, and we don't have any for confetti. To which I would say, Facebook does. Like, there's places that have confetti. Twitter has like these balloons sometimes on your birthday. I think I've seen Medium have confetti as well. So like, don't discount this. This can be useful. But I do take the point that like this is not everyday code. So let's look at something more mundane. Let's look at an email client. What could be more whimsical than email? Oh, I should do a demo. That means that I have to tab over. Oh, don't do that. Oh, goodness. Click there. OK, does this look good? Yeah, it does. So this is a fictitious email client with a fictitious email written by the real Ken Wheeler. I did not write this. Please don't attribute it to me. If I reply, he was very kind to do that. I really appreciate it. I can reply to an email, or I can compose a new email. So let's write some stuff. Maybe I'm not happy with that, so I clear it, and then it etch-a-sketches away. But no, let's say I want to actually send it. So I'll add a subject and some text, and let's click send. So it folds itself up and shoots itself away. And then there it is. I can also save a draft, which does pretty well the same thing. There's a few things I'd like to focus on with this demo. The first is that this idea of nodes being relative to where they should be. So when I click reply, a compose email modal pops up. It's the same modal that pops up here, but by positioning it differently, you instantly give the user context as to what they're doing. So you don't have to rely on the like RE in the subject to realize this is a reply and not composing. So that's kind of neat. But even more important than that is the fact that when I save this, you'll see that it moves to the drafts. Like it takes your eyes on a voyage to where that UI needs to be. And I think this is really important because surely it's happened to other people and not just me. Maybe it's just me. But I find that when I'm using a new application, let's say like I'm writing a Medium post and then I save a draft, you will never find that draft. It will be hidden in a submenu and it will be the challenge of a lifetime to find it. And I think like this is a standard discoverability problem that apps have. And the way that you solve that typically is like with an onboarding wizard, right? So you have that thing, you sign up for the first time and it's like tooltip 1 out of 47. This is what this link does. And like everyone hates these things, so you like escape out of it as quickly as you can. And as a result, you don't know how to you don't learn how to use the app. And so then you run into this problem where you're frustrated. And eventually it's so frustrating that you uninstall the app and you like chuck your phone out the window and you decide that you're gonna go live in the woods like a recluse. This is not the future that I want for my users. And so how do we solve that with this? Well, it's literally showing you how to use it. You will never wonder where the drafts are because by saving it, it takes you there. And then there they are, drafts. So that's neat. The other thing, and it's related, is that I'm making a distinction between an action-driven animation and a state-driven animation. So React gets you to think about state, right? Like, remember the expression or the equation, your UI is a function of state? So when you animate, you often have like a Boolean, like is open, and then you just set the opacity based on that Boolean, so that when I open a modal, it fades in. When I click out of the modal, it fades out. But this business here with sending an email or saving a draft, that's just a close modal animation. It's the same state change as when I dismiss it by clicking out of it. But because the animation is different, it gives you a lot more context, right? There'd be no other way with the animation to tell if you had saved the draft or sent an email or just clicked out of it to dismiss it. And you could have like a toast that pops up in the corner that says that, but that's like distracting and it's after the fact. It's unnecessary. The animation can tell you that. Let's go back here. So this is not like my idea. This is by someone named Tobias Allen, who has this wonderful blog post about the difference between action-driven animation and state-driven animation. He also has an email client demo. I stole the idea of an email client demo from him. Hopefully he doesn't mind. The third thing that I want to talk about is this folding animation. And this is like my favorite part of it. I like it because it's whimsical, right? It's like a throwback to the days of snail mail, where you like, and here it is really slowly, just so we can all look at it. So you fold it up like a letter, and then you put it in an envelope, and it's like this skeuomorphic thing that, because it's not like the actual aesthetic, because it's like the animation, it still feels current. So I think that's really cool. Where's my cursor? So I showed this demo to people, and a response I got was that, yeah, that's really cool and all, but like imagine you're a serious business user and you have email to send. Are you really going to force them to sit through this animation running? It takes like a second and a half. Like they're going to get really sick of that. And my response to that is like, yeah, of course, right? Obviously. And there's a solution to this that does not include not having nice things. So like an analogy is, let's imagine I come up with a really funny joke, like the best joke anyone in this room has ever heard. Were I to tell this joke, it would be pandemonium. People would be rolling on the floor. It's like the best joke ever. But it would not be funny the 70th time I tell it, right? I could continue to stand here and tell it, and it wouldn't be long before Gerard comes up with a cane and like pulls me off the stage. Right, so why don't we just write animations that change over time, right? It's not like a hard problem to have a bit in local storage that keeps track of how long you've seen the animation and to like make it quicker or shorter or change it, right? Whimsy is supposed to be unexpected. That's part of my definition. So if it's just this routine part of the process, of course that's not going to be enjoyable. So there's a solution. But let's look at how this works. Folding the DOM. So here I have, where's my cursor? Oh, and I can't see the button. This is going to be challenging. Okay, so here I have what appears to be an image. I rotate it. It still appears to be an image. But in fact, it's 3 images. And more specifically, it is 3 DOM nodes that each contain the same image. So when I mouse over them, you'll see what's what. The only thing this mouse over is doing, aside from making the ones it's not mousing over translucent, is removing overflow hidden. So that should be like a bit of a hint as to how this works. This DOM node is, let's say, 200 pixels lower. And so it's offsetting its children by the opposite amount. So it's negative 200 pixels. So the image is translated up. And then by constraining the height with overflow hidden, you get this cool effect where like each box appears to be part of the same box, but it's this whole separate thing that includes the entire contents. And so once you do that, no, not that, it becomes pretty easy to do this because it's just a CSS rotation, right? Like the top one has transform origin bottom, and it's just CSS. So when I work with ideas like this, I try to have it so that the component is the method of encapsulation for this idea, and we're abstracting the behavior, not the UI. So I could have this be like foldable image, and it could do the same thing where you just give it an image SRC, but then like it wouldn't work on a form like I have in my email demo. So let's look at this. We have an isFolded prop, true or false, whether or not it's folded. The children are like the thing that you're rendering, and then we have a duration which defaults to 1,000 milliseconds. If we jump down to the render method, you'll see we're rendering 2 things, the original copy, which is like the actual thing, and then a folded copy. And we only render the folded copy when we're folding. So we look at the original, and this is like essentially just rendering children, but we're wrapping it in a div, and for 2 reasons. The first is we need to capture a reference to it, and the second is that we want to set an opacity so that once we start folding, the original goes away, and then we're just dealing with the folded copy. So the folded copy, meanwhile, uses getBoundingClientRect, which is a method to figure out where in the viewport an element is. And once we have that, we can position the folded copy like right in front of the original copy, and then we're hiding the original copy. So it's like this covert like swapping it in. And we apply the top, left, width, and height to the style to make sure that it's right where it needs to be. Then we have this like gross looking chunk of code that, to be honest, I'm not interested in going over in depth. But the key bit is that we're taking the outer HTML and we're cloning its HTML to be as input this like top fold. So we're copying the HTML content of that node into this top fold. We're doing it dangerously, so definitely scrub inputs when you do this. And then we do the same thing for the middle and the bottom. So we have these 3 copies of the original node, and that's how this folding animation works. And that's all there is to it, kind of. I mean, not really, because there's all of this CSS to make it work. And this CSS is not like next-gen crazy CSS. This is your grandmother's CSS, right? Like, this is just standard CSS stuff. But this is why React is awesome, because CSS is only reusable at the class level. You can come up with a class and use that everywhere, but you can't come up with a group of markup. And so there's all of the CSS to use, but when we're using the foldable component, it looks like this, right? Like, we don't have to worry about any of that. So this is a compose email. This is like, imagine the state manager for that email composition flow. So we have a status, which is composing. So like the modal is open. We're not sending it yet. We have a way to send it, and then what we're rendering. So we have this foldable component that's just going to fold up its children, and its internal state is based on our domain status. So like we don't have to specify, I mean, I guess we do have to specify whether it's folded or not, but it's just based on based on the state we already have. So we don't have to go out of our way to figure out how that works. And then we just render a child, in this case a letter. Another thing that I think is cool is node transporter. So this is the React storybook, like the MVP of it. So you'll see I click on a button, the child pops out, I click on a different button, it gets swallowed into it. So that's kind of neat. The first thing we need to know to solve this problem is to figure out where in the viewport those 4 buttons are, right? That's the key insight that we need for this to work. That should not be there. And for this, I have a node provider. So Ken was gracious enough to explain the new React Context API, which this uses, and hopefully that means I can skip through this a little quicker. So we have this new context that we're creating for nodes. There's 2 things this node provider cares about. One is just a mapping of all the nodes that we have with some ID, and the second is a way to capture nodes. It may look a little funny to have a function as part of your React state, but this is just so that the state, like, we can just pass this as an object, and it's not going to re-render because it's not a new function every time. And so for the provider, we just pass the state as the value, and then we export a consumer to consume that. That's a lot of words, so let's look at how it works. So here we have a node provider, which, as Ken said, is like your Redux provider that just wraps your entire app. Then we have this inbox heading somewhere in your app, and this is a node we care about, right? Because this is the node that our modal is supposed to shrink into. So we use the node consumer, which exposes the ref capturer function, and then we can use that ref capturer function with the native React ref. We just give it a name first. Then somewhere else in our app, we need that inbox header. So again, we use the node consumer, and then we have this nodes map available to us. And as long as nodes.inboxHeading is mounted, it will be available for us to do whatever we need with, including finding its coordinates using getBounding client rect. So I don't have the time to go into this transport component in depth, but I can give a high-level understanding of how it works, hopefully. So we have 2 buttons we care about, the from in the top right, the to in the top left, and we have a child, which is this yellow boxed modal that we have. When the status of this modal changes from composing to sending, we want to like shrink it up and get it into the to box. So we can figure this, it's just about doing the math, right? So we know where the yellow box is because that's the child of transport. We can just get the bounding client rect for that. And we know where child end is because it's in the middle of our to node. So it's like, I don't know, 700 pixels to the left and maybe 25 pixels up. And then it also scales from 100% to 0. So this is just a CSS transform. You can figure out the translate and the scale. And then away it goes. Let's look at how we would implement this. So we have this transport usage. This part is unchanged. So we have the same like compose email. It has a bit of state, and then it has a way to change that. We have to figure out what the status of the transport is. And so if we're composing, that means the modal is open and it's open. If any other state, like if we're sending, it'll be closed. So we have our node consumer, which makes available the compose button and the outbox heading, the 2 nodes that we care about. Then we have a transport component, which uses that status we defined just above, as well as the 2 nodes it needs. And then this is unchanged from the previous slide. It's the foldable letter that has the foldable component, which wraps the letter. And so what's really fun about when you use like behavioral components like this is you can compose them like little Lego blocks, right? We often think about the Lego blocks as our UI, but we can also use them for behavior, which is like really fun and cool. It is a bit of an oversimplification, and I say that because in the email demo, we want to fold it and then transport it. We don't want them to happen simultaneously. But to solve that, it's just about having an intermediary status. It's just about adding one more state, like sequencing it that way. In conclusion, hey, I'm actually on time. There's a lot of really unexplored territory in this space. So I started building things for the web a while ago, and I remember someone telling me that the most interesting problems to solve were the ones that hadn't been solved yet. And my response to that was like, yeah, I'm sure that's true, but most problems are solved. At the time I was a Ruby dev, and so there were a bunch of Ruby gems, right? Everything you can think of has a gem. And the things that don't are the like big hairy problems. They're so advanced that like I will not be able to solve that. You need a team of people with CS degrees and tons of experience. It turns out that's not really true though, which is really cool. So this is a circle. If we look at it, you'll see that it's not quite a circle. It's warbling a little bit. My partner gave this a name of a wibbly wobbly circle, and I like it, so that's what I'm sticking with. This is a wibbly wobbly circle. There's a lot of React animation libraries on NPM, and a lot of them do really nice things and are really helpful, but most of them are just like syntactic sugar over web APIs, like CSS transitions or the Web Animations API. It'd be cool if there was a component on NPM that I could just use and give it children, and it would add a warbly background to those children, right? There's a lot of like cool ideas that just don't exist yet. And I didn't make that, so feel free to take it. The future is also really exciting. So this is, WebRender is Firefox's new rendering engine. This demo may not look that impressive, but if anyone's done CSS animation, there's this golden rule. The only properties you're supposed to modify and animate are transform and opacity. If you animate any other property, you won't be able to hardware accelerate it, and it's going to run choppy. WebRender, Firefox's new rendering engine, changes that. It hardware accelerates any CSS property. So this demo, which runs on my computer at about 55, 60 frames a second, is 600 DOM nodes that are each being positioned using top and left, and each being sized using width and height, like the CSS properties you would use normally. So that blew me away. Like, we're moving towards a future where we no longer have this very limited subset of CSS we can use if we want to animate it, which is really cool. I was working on this talk, and I had like a moment of crisis, to be honest, where I realized, like, why am I advocating for us to like spend our time on these whimsical touches when so much of the internet is broken for a bunch of people right now? And I think what I came up with, the way I reconciled that, is that there's like a Maslow's hierarchy of needs things here, where at the base level we want our products to be usable. And once they're usable, then we can like indulge ourselves and focus on making them delightful. But we should definitely make sure that the things we're building work for people before we get onto this stuff. So if nothing else, we should make sure that the whimsical touches that we're adding aren't like actively contributing towards making people feel sick or unhappy. I guess sick is the focus. So there's this category of disorders called vestibular disorders, and as I understand it, it has to do with the inner ear and the part of the brain that regulates balance. And so if you have a vestibular disorder, you may be prone to motion sickness or vertigo. And so the confetti demo from earlier might upset someone. Like, it may be too much motion, and it might make them feel sick. And like, we don't want to do that, right? We don't want to make our users feel sick. So there's a CSS media query called prefers reduced motion. And because it's a media query, we can access it in JavaScript using match media. And so we could just use this property and then not do the confetti animation if that property is true. It would be great if that's where I could end it and we could move on with our lives, but we can't because the CSS support is awful. I hope that this will change. For now, it only works on Safari and iOS Safari. So at Khan Academy, what we do is we have a property on our user model, so you can go into the user settings and you can tick a box, and then if either that property is true or the browser setting prefers reduced motion is true, we skip the confetti animation. The takeaway, aside from accessibility being really important, please don't prioritize any of this over accessibility, is that animations and interactions are this like really important part of the user experience. And there's a lot of unsolved problems that are like, frankly, really fun to work on. This is also like getting so much easier as the web platform evolves. And like, you can really expand your toolkit with this. Like, so I work with other developers and with designers, and something I hear a lot, almost done. Something I hear a lot is that like the design will have this product idea, and someone, maybe myself, will say, like, that's cool, but it's non-trivial, right? Anyone heard that term before, non-trivial? Imagine if we could expand the universe of what is trivial so that we wouldn't have to say that when design comes to us with a cool idea. That's what I'm thinking about a lot, and it's a really fun space to be, so come build stuff with me. Yeah, my Twitter is that. I just scheduled the tweet that hopefully went off that has the links to the slides and codes and resources for all of this stuff. Thank you.